Alright, so in this video, we're going to be talking about arc length with polar. So first off, we know our parametric arc length equation, right? We've went over that before. That is the integral from alpha to beta of the square root of dx dt squared plus dy dt squared dt. Now, using what we know about the parametric arc length, we can find the polar arc length, alright? We just do some substituting. So here is our polar arc length equation. We get the integral from a to b of the square root of r squared plus dr d theta squared d theta. Alright, so using this, now we can find the arc length of something. If we wanted to find the arc length of r equals 2 sine theta, well, first we need to understand what that graph looks like, right? And r equals 2 sine theta is just going to be a circle up here. There you go. Right? Because like 2 cosine theta would have been a circle over here. Okay? Whereas 2 sine theta is the circle kind of like upwards, I guess. Now, if we want to find the arc length of this, well, what are we going to be integrating? What's going to be our bounds here, okay? Well, that's just going to be from 0 to pi, right? That'll cover it all. And then our integrand, right? We have a r squared, that's just going to be this squared, and then dr d theta. So we're going to need to take the derivative of this and then square that. Okay, so let's try that. So we get the integral from 0 to pi of the square root of r squared, that's going to be 4 sine squared theta, plus it's going to be the derivative of this, which is going to be 2 cosine theta, and squaring that you get 4 cosine squared theta d theta. You can pull out a 4 here, which means you can put a 2 on the outside. To the integral from 0 to pi of, now you're just left with a sine squared theta plus cosine squared theta d theta in the radical. So you can just say that your integrand is just d theta. So 2, the integral from 0 to pi of d theta, which means that you are going to be evaluating 2 theta from 0 to pi, and that's going to give you 2 pi. Alright, does this make sense with what we know about just the circumference of a circle? Well, first off, r equals 2 sine theta, that is a circle with a radius of 1, okay? And our circumference equation that we learned so long ago is c equals 2 pi r. Well, we have a radius of 1. That means our circumference is equal to 2 pi. Again, so much more efficient to do it this way. Yep. So, yeah, that's basically going to do it for this video, and I'll see you in the next one.
So if this video helped you, make sure to leave a like and subscribe by clicking my icon in the top left. You can also view the playlist for parametric and polar in the next video in the series. See you soon.